Okay, so Mr. Ups here, so we are told the rate of decay of a substance y at any time t is directly proportional to the amount of y. So the rate of decay, so that's dy dt, because it's a rate of dt of the substance y at any time t, is directly proportional to the amount y and is also directly proportional to the amount of another substance x. So that, and the constant proportionality is negative 1/2. The value of x is given by this. Well, what this means is that they're both proportional to x, to y and x, this rate. Well, then it's going to be negative 1/2 is my constant proportionality of x times y, because they're both directly proportional. And so, well, I know that x is related to t in this particular way, so then I can say dy dt is simply negative 1/2 times 4 over 1 plus t squared times y. Simplifying this a little bit, I know that that becomes a 2. That's just a simple simplification. And so now I'm going to try and separate my variables. So I'm going to divide by y. So 1 over y dy multiplied by dt is equal to negative 2 over 1 plus t quantity squared dt. So I move the dt over by multiplying both sides by it, divided by y. And so now I'm going to integrate the two sides. This particular side here is going to be the natural logarithm of y. And that is going to equal to, I'm going to take out my constant. And I know that this is the same as 1 over, or let me say that again, it's a negative exponent. So it's also the same as negative 2, which I've taken out, 1 plus t to the negative 2. So I'm going to take my value here, add 1 to it, add 1 to negative 2 gives me negative 1. And then I have to divide by the reciprocal of this value, which makes this a positive, plus c comes my way. And so my function then, I know that ln y is equal to 2 over 1 plus t plus c. All right. And so given the initial condition is y is 10 and t is 0, I can find what y is. So y equals 10 when t is equal to 0. Well, if I put y is 10 in there, let me rearrange this first. Let me solve for y first. Sometimes it's easier to plug the values in at this point. Sometimes it's easier to solve for y first. And I'm going to solve for y first, which means that I'm going to raise these both to the power of e. So y is equal to e to the 2, 1 plus t plus c, which is simply y e to the 2, 1 plus t times e to the c. E to the c is just a constant, so I don't have to keep it e to the c. I can just rewrite this as some other constant. Y is equal to some constant, we'll call it a, e to the 2 over 1 plus t. And so now I am ready to use these actual values here. I'm going to plug 10 in, is equal to a, e to the 2 plus t is 0. That's 2 plus 1 over 0. So a then is going to be 10 e to the negative 2 is equal to a. Just to make sure I didn't do that too fast for you, I'm saying that this is equal to a e to the power of 2. And so if I multiply both sides by e to the minus 2, e to the minus 2, or that's the same thing as dividing by e squared, same. So a is this value here, and so then y is equal to 10 e to the negative 2 e to the 2, 1 plus t. So here is my initial value of my, how do I say it? Here is the function explicitly defined as t. And then finally it says, determine the amount of substance that remains when t becomes very large. Well, when we look at our particular function, when t gets really big, goes to infinity. That means on the bottom of this function here, it's going to get really big, which means that this whole fraction will basically become really, really small, like super small, basically 0. And so e to the power 0, that means this value here is going to go to e to the power 0, which we know is 1. Anything to the power 0 is 1. And so after a very long time, y will end up going to 10 e to the minus 2. This is where it will tend to go towards when t gets very large. So analyzing these kinds of things when t is large is an important skill that you'll see, especially in the next chapter.